The semi-automatic transaxle is a newly incorporated system from Hyundai Motors. Therefore, this VTR tape is mainly focused on providing system construction and the function of each component to help effectively understand this new system. In particular, it includes learning modes in detail, which definitely should be followed when replacing parts. The advantages and disadvantages of the semi-automatic transaxle. Mechanical differences between the manual transaxle and the semi-automatic transaxle. System construction of the semi-automatic transaxle. Operation mode, diagnosis. Oil replacement. And operating instructions. The semi-automatic transaxle is a shifting system which has the comfortable drive of the automatic transaxle and the economical strength of the manual transaxle. It provides a lower fuel consumption rate and cost than that of the automatic transaxle. Moreover, the semi-automatic transaxle allows drivers to perform comfortable and active driving by shifting the gears without operating the clutch pedal installed in the manual transaxle. The major difference between the semi-automatic transaxle and the manual transaxle is in the clutch pedal mechanism. In the case of the manual transaxle, pressure is applied to the master cylinder when the clutch pedal is pressed down. For the semi-automatic transaxle, however, the DC motor of the semi-automatic transaxle generates and sends it to the pressure into the master cylinder, because the semi-automatic transaxle has no clutch pedal mechanism. The engine torque is transmitted to the transaxle corresponding to this pressure and the clutch diaphragm force. The semi-automatic transaxle system is composed of 7 sensors, the semi-automatic transaxle control module, and 4 parts to be controlled. The 7 sensors are engine RPM, the gearbox input speed sensor, the throttle position sensor, the push-pull sensor, the gear position sensor, the clutch release cylinder position sensor, and the actuator position sensor. The 4 parts controlled are the power control unit, the electric valve starter relay, and the buzzer. The engine RPM signal is sent to the semi-automatic transaxle control module from the engine control module. It determines operation time of clutching and declutching with the gear speed sensor. The gear speed sensor attached to the transaxle case as a whole sensor type detects the rotation of the input shaft and feeds input shaft speed to the semi-automatic transaxle control module. The measuring range is from 100 to 8,000 RPM. The throttle position sensor utilizes a variable resistor to monitor the throttle position. By the opening amount of the throttle, the semi-automatic transaxle control module is able to calculate engine load and vehicle acceleration. The throttle position sensor's maximum value is 4.97 volts. Its minimum value is 19.5 millivolts, and the idle range is 6 to 19% opening value. The push-pull sensor is placed inside the gear knob. The switch inside the sensor becomes an open or closed circuit according to lever operation. An on-off signal is sent to the semi-automatic transaxle control module so that it is able to recognize the intention of the driver shifting. This sensor has 12 plus or minus 4 Newton meters of operation force and 60 degrees of operation range. The gear position sensor located on the gearbox control rod monitors the current gear position, sending signals to the semi-automatic transaxle control module. The gear position sensor measures the passage movement, which is in the up-down movement of the shift lever, as well as selection movement, which is the left-right movement of the shift lever. And also, the gear position sensor detects the initial gear connection and the present gear position, providing a basis of operating clutch engagement, disengagement. The operating range of the gear position sensor is 60 degrees in selection and 30 millimeters passage direction. The clutch release cylinder position sensor has a function of monitoring the operating distance of the clutch push rod and compensating clutch wear adjustment. The actuator position sensor monitors the position of the DC motor, controlled by the power control unit, feeding signals to the semi-automatic transaxle control module. Now, we will take a look at the output items controlled by the semi-automatic transaxle control module. The power control unit operates the DC motor on receiving the signal from the semi-automatic transaxle control module. The power control unit becomes ready for operation by receiving the ignition on-off signal. The parking brake is available when the ignition is set to off. The orders power control unit is composed of an inhibitor signal and a command signal. The command signal functions to engage or disengage the clutch through the operating DC motor on the basis of the duty signal of the semi-automatic transaxle control module. A 50% duty value indicates clutch engagement and disengagement. A duty value below 50% indicates the operation of the DC motor to disengage the clutch. And a duty value of above 50% indicates the operation of the DC motor to engage the clutch. Namely, the DC motor's operating speed is controlled by the duty value of the command signal. The inhibitor signal, which controls the command signal for the DC motor operation, controls shifting time. Consequently, shifting time is determined by the inhibitor signal, and the DC motor's operating speed in the shifting process is regulated by the duty value of the command signal. The DC motor is controlled by the power control unit. The clutch is supposed to be disengaged when the DC motor operates counterclockwise and applies force to the link and spring, generating pressure into the master cylinder to operate the hydraulic system. In reverse, the clutch is supposed to be engaged when the DC motor operates clockwise and applies force to a diaphragm spring. The electric valve, which is of the normally open type, functions to open or close oil passage by the duty signal of the semi-automatic transaxle control module. When the ignition is on, the electric valve closes the oil passage. When an actuator malfunction is found, the electric valve is opened to engage the clutch by using diaphragm force. In addition, the electric valve functions to compensate for changes in the clutch release cylinder operation distance caused by oil expansion and clutch wear while disengaging the clutch. The start relay operates at some special conditions to prevent an unexpected accident when the vehicle starts. The start relay allows the engine to run only if the gear is in the neutral position and engine RPM is below 500. A buzzer is designed to warn the driver about system conditions. Let's see the operating condition of the buzzer according to situations. First, correct functioning of the processor sounds 2 beeps as power is turned on. When push speed is reached or is not in the neutral position, 1 beep sounds. With clutch abuse, it sounds continuously for 400 milliseconds every 400 milliseconds. Bad gear ratio, it sounds continuously for 800 milliseconds every 800 milliseconds. Fault in control components. Not an operating procedure. And contents of permanent memory are incoherent. It sounds continuously for 400 milliseconds every 10 seconds. The terminal voltage value of each component of the semi-automatic transaxle and semi-automatic transaxle control module is on the table. Check the voltage and the resistance at each terminal when the diagnostic trouble code is encountered or sensors need to be checked, referring to the shop manual. In this turn, we will see the function of the semi-automatic transaxle. The control mode consists of 5 categories: engine starting mode, vehicle drive mode, gear shift mode, vehicle stopping mode, and engine stopping mode. The semi-automatic transaxle enables the engine to start by operating the DC motor to disengage the clutch within 250 milliseconds when the ignition is turned on. The system is energized and the gear lever is in the neutral position. The condition of engine start is gear lever in the neutral position, engine stopped, and clutch disengaged. However, if battery voltage is too low, the starting mode will be changed to the pushing mode. Turn the ignition on when the engine doesn't start due to low battery voltage. Push the vehicle to reach approximately 5 kilometers per hour and then shift into second gear so that the clutch gets engaged and the engine starts. On this occasion, the buzzer sounds as the vehicle speed reaches about 5 kilometers per hour. However, in this pushing mode, battery voltage should be above 8.5 volts to operate the DC motor, and no malfunction should be found in the semi-automatic transaxle components. The vehicle drive mode is broken down into accelerator pedal operation and rolling action. The required conditions for the starting mode by accelerator pedal operation are when the vehicle is stopped, the engine is running, and the gears are disengaged. In this condition, if the accelerator pedal is depressed after shifting into first, second, or the reverse range, the engine RPM will increase and the clutch will engage. When the clutch is engaged, the speed of the engine and the input shaft will synchronize. The required conditions for the vehicle drive mode by rolling action are that the gear is engaged when the vehicle is on a downhill slope and when the gear speed sensor is higher than the engine RPM. This is to escape the possible danger of causing freewheel movement on tires when the clutch is disengaged. To eliminate the possibility of such danger, the clutch is engaged regardless of the accelerator pedal when a gear is engaged. The clutch is disengaged as enough force is applied to the gear lever after releasing the accelerator pedal. When a gear is engaged by shifting, the clutch is ready for engagement. At this moment, the depressed accelerator pedal begins the shifting mode. However, if vehicle speed is excessively high, clutch engagement will be limited to avoid overrun. Under the engine running and the clutch engaged condition, if the brake pedal is depressed, the clutch will quickly disengage to reach an idle RPM and the vehicle will stop. When the ignition switch is turned off after the vehicle is stopped, the clutch returns to the engaged condition and the system will be stopped. The engine starting mode makes it possible to restart the engine, and it is the function of the semi-automatic transaxle control module to run the vehicle by continuously performing previously explained modes. The diagnosis of the semi-automatic transaxle system is possible only by the high scan with the following 5 functions: diagnostic trouble code, current data, flight record, simu-scan, and the learning mode. First, let's see the diagnostic trouble codes of the high scan. Please refer to the shop manual for more detailed description of the related parts when a diagnostic trouble code is encountered. Next, current data functions. This data assists technicians to effectively diagnose and repair the vehicle by knowing the current vehicle state. The flight record mode provides the function of recording the value of selected sensors which need checking. A system malfunction might be easily detected and repaired by reviewing memorized data coming from the flight mode of the high scan. The learning mode is used to determine whether the system abnormality remains or not and initializes the initial value of the gear position sensor and clutching point. In addition, the learning mode must be conducted when the semi-automatic transaxle system is manufactured or when such parts as sensors, actuators, or clutches are replaced. The engine will not start if this mode is not followed in the manufacturing process. Moreover, the engine will not run, or even if it runs, shifting shock and increased clutch slip may occur in case this mode is not fully conducted after replacing or adjusting sensors, actuators, or the clutch in the field. The learning mode procedure takes 2 to 3 minutes. An initial screen will be displayed if the learning mode is chosen. Following the order on the screen, turn the ignition switch off 5 seconds after turning the switch on, and the learning mode will begin. Press the yes button if the buzzer sounds. If not, press the no button. In case the buzzer doesn't work, check the buzzer-related items and try again. The position of the actuator and the clutch release cylinder, with the mention of successful initialization, will be displayed on the screen if the buzzer normally works. When the hydraulic system is faulty, check and repair hydraulic operation-related items and perform the learning mode again. Pay particular attention to the air bleeding state. The learning mode of the throttle position sensor shows up on the screen. Press the enter button after fully depressing and releasing the accelerator pedal to retrieve the throttle position sensor value. If the throttle position sensor associated items are defective, repair and try the learning mode again. With reference to the learning mode of the push-pull sensor, press the enter button after shifting the gear lever into neutral, and press enter after shifting the gear lever into third. In the same way, do this for the fourth gear. If the push-pull sensor related items are faulty, check and repair them and try the learning mode again. The learning mode of the gear position sensor shows up on the screen. Press the enter button after shifting the gear lever into the first, second, third, fourth, fifth, and the reverse and turn. Keep that condition for a while, verifying whether correct shifting is conducted, and the left-right value of the gear position and shift will be displayed on the screen. In case of that the learning mode is not progressing, do the learning mode again. If still negative, check and repair the expected items and try the learning mode again. Press the enter button when the engine starts after shifting the gear lever into first. If not, press the no button. When the learning mode is no longer progressing after the engine starts, try the learning mode again. If still not, check and repair the gear position sensor related items and try the learning mode again. Press the enter button when the engine starts after the shifting gear lever is in neutral. If not, press the no button. If the engine doesn't run, the starting system malfunction is expected to be checked and repaired. After that, try the learning mode again. Please install the manual vacuum pump and sub-oil reservoir as you see on the screen. Under the ignition on state, open the bleed screw and operate the vacuum pump up to 700 millimeters Hg at least. Turn the ignition key off for 4 to 5 seconds and fill the reservoir with oil. Repeat this process 2 times. Check if air remains in the tube. If there is a bubble in the tube, perform the air bleeding process more so there are no bubbles, and then close the bleed screw. Measure the stroke length of the push rod in the clutch release cylinder while turning the ignition key on and off. The normal measuring value is 11 millimeters. As a characteristic of the semi-automatic transaxle, it is recommended to start the vehicle on a downhill or uphill slope by using the side brake. The push-pull sensor placed onto the gear knob is so sensitive that frequent gripping of the gear knob might cause declutching. So far, we have briefly learned about the semi-automatic transaxle system. We hope this information helps you understand, and please take reference to the shop manual when trouble is encountered.